It's a pleasure to have here Otto Reinke, who has been testing with us for quite some time now. And you know him already from previous presentations, but now he has a product that, yeah, good
Okay.
to present, right?
Okay,
So,
great introduction.
floor is yours.
Thank you, Dan. Okay, as Daniel has already mentioned, I'm quite close to the Focus Center since a couple of years, and we have done quite an interesting journey together. And today I will show you a little bit where we as TWE Wind Energy are located and how far we are at the moment with our product. You have to show me my presentation, then I can show you something. Okay. Normally, we always start with a kind of vision or what we are believing. So as TWE Wind Energy, we think that the energy system of the future will be to a largest extent decentral, renewable, autonomous, and it will be small. It will be a combination of photovoltaic systems and small wind turbines, and they will have their place in the market for in the future. This will be for sure. We as TWE Wind Energy have started a couple of years ago with the development of our small wind turbine, but it has not started from scratch. We have taken over the basic development, which has been done by some companies in Germany called SMA, Solar Technology, from Aerodyne in Rendsburg and from ISET in University in Kassel. So they have created the basic development for the small wind turbines. We took it over, and then we have started the redevelopment of this concept. In the end, in our starting point was the following. You see here where we have installed the first wind turbine here at the Focus Center. At that time, we have a small wind turbine, 5 kV, horizontal axis, with passive stall and with which was a downwind concept. And we were using pultruded rotor blades. That means we have a rotor blade which is designed in two dimensions, in two directions, without any twist. It was, in terms of production cost, quite impressive, I have to say. But we were facing some problems with it, and therefore we have to completely renew the development. We were starting with the machine unit. The basic idea has not been changed at that time. The basic idea was we want to have a single frame housing like we have in the automotive industry. We want to have an easy commissioning and easy exchange of the product. And we want to have a protection against external media, corrosion, and so on. And therefore, we have adopted this concept, which has been developed by this group of companies before. And we were looking for a good supplier to create this, or to bring this idea to reality. With them, we developed a new bearing concept. We have a new RPM measurement concept. The brake system has been completely reworked, and also the safety chain with centrifugal switches, temperature switches, and vibration switch have been completely new installed for this concept. The next one was then, the next challenge was then to make a redevelopment of the controller concept. The previous one was a complete new project, and we had to replace new functions inside, like control functions, as well as monitoring functions. Reactive power control we have integrated. Of course, the VDE concepts in a lot of countries, the requirements for grid protection have been raised, so therefore also we have to take this one into account within the development. And we used also standard components in order to secure an easy to repair process. And of course, also remote system monitoring and parameter change we could also realize with this product now. One challenge was definitely the downwind concept. The downwind concept itself it's great because you need no wind vane. The wind turbine is always orientating itself to the wind. It's great. But the big challenge and the big problem was noise, because the wind is always coming first through the tower, and then going on, and then it's creating wakes. And the wind turbine, the rotor blade is always cutting into the blade, into the wakes. So therefore, we tried really a lot of things in order to optimize this concept, but this was not possible. Afterwards, finally, we decided to make an upwind concept out of it. What we have done is we have, for this downwind concept, we have tested different rotor blades. We have 5 different rotor blade profiles tested it. We had pultruded rotor blades. We had twisted rotor blades. We have made simulations, field tests, different cone angles, tilt angles. We did really a lot. We also used different materials, but as mentioned, we could not get rid of the noise in a downwind configuration. So therefore, we make an upwind. It was a lot of work, not only in order to find the right profile, but also in order to fulfill the requirements for testing it. So especially here for this rotor blade has a length of 2.5 meter, and we have to have some testing requirements the classical way. So we had to put 200 kilos on this rotor blade on 2/3 of the length of the blade, and it has to survive without breaking. So, and this was done in the end very successfully. We have now 2 rotor blades materials. We have this rotor blade profile in wood as well as in glass fiber, and both have passed successfully this testing. Then we had when we create an upwind wind turbine, we have to see what is necessary in order to steer it to the wind. The classical way was to have it in a kind of with a wind vane. Also, this one we have tested, but this was not successfully at that time, because due to the load on the wind vane in the end, there was so much load on it that we had faced problems to fix it on the current machine housing. And therefore, we have decided, no, we will go in a different way. We will put there a yawing motor. So we are very unique, I would say, in the 5 kV segment of small wind turbines, using a yawing motor in order to steer the wind turbine optimal to the wind. That means we have an anemometer system. We are measuring wind direction, wind speed. The information goes to the controller, and then we align the wind turbine optimal to the wind. Other challenges are also the lattice tower. Our idea was always to have a wind turbine which we can erect without a crane. So we have standardized modules of 3 meter, and we can configure a 12-meter tower, a freestanding 12-meter tower, and an 18-meter guide tower with this configuration. It is like a telescope concept. We can put the elements inside. We have a length of 3 meter roundabout, and we can transport it very easy with a trailer and a car. We can transport the whole small wind turbine wherever we want to. Due to the yawing motor, we also had to change the design. We tried a lot of different projects. In the end, we came to the bubble or to a ball design. So Anacon has his egg, we have the ball. And it has some very good possibilities to make also to individualize it. The nacelle cell itself is a fiberglass housing, and which is protecting, of course, then the machinery, and it's also directing the airflow to the machinery itself. But also, we are planning to have customized designs. You see it here at the moment on the right-hand side, a little bit like a Pokemon. You see it in the top right. Or we can also have a kind of art edition. People were also coming and saying, we like to have it with the Earth, in form of an Earth. We say, okay, it's no problem. And there are also some coming from Star Wars and say, we want to have the Death Star in this design shape. Okay, it's a little bit challenging, but we are used to it. So in the end, we have now a product, 5 kV horizontal exit upwind passive stall active yawing system, 2-stage induction generator, 3-phase, 50 Hertz, 400 volt. So that is where we are now. But we also talk about partnerships today. And this was not, this to create this product was not possible with strong partnerships. A lot of this development we have done here with the Focus Center, where we have, in the meantime, a very good and very familiar relationship, I have to say. And the focus was here in the rotor blade, the yawing system, and the controller. Currently, we are working also on the duration testing, the safety and control testing, and noise testing, which we need here for the certification process for the Danish market. Partnerships for the development, production and development. I'm always a friend of using the competence of people who really are strong in a certain field. So I involved in the beginning of the development process also already my suppliers. So in total, and you'll show it in the end, I have 5 strategic suppliers for the whole wind turbine. And with them, I have developed and optimized the different products. The advantage is for me, I have access to industrial production and know-how. I can save investments in productions because as a startup, you can imagine, you cannot invest so much money into a production facility. We can increase competitiveness and flexibility because the dynamic, especially in the beginning, the dynamic of the market, I can shift to my suppliers. And I can reduce, of course, my high fixed cost. So therefore, you see here, this is a little bit to visualize partnerships for the nacelle, for the machinery, for the tower, for the controller, for the design, for the nacelle housing, and for the rotor blade. And in the end, I press the button, I get 5 packages, and my wind turbine is ready. And aside, of course, we have also the know-how carrier with the Focus Center. We're also using here the competence of the of Groningen, of the Hanse Hogeschool, and also of the Hochschule Emden-Lehr in Germany. In the meantime, with these guys, we're also preparing a new project, which hopefully will start in spring next year. So references to I have erected, one is here at the Focus Center, the another one is in Germany. We have erected, and now we are starting to make to start with the market entry and with the sales, because in the end, the small product has to find the way into the market. Target groups are, as a lot of you also know, agriculture, commercial industry, public facilities, private households, and we're also using small wind turbines as an advertising medium, because if you see what does it cost to have a billboard for 20 years, maybe this is also a better alternative, because you can also create some energy out of it. How will it see? CI branding. There are some examples how we can create also our small wind turbine. For example, adding different logos or logos of companies to these wind turbine. Next step will be definitely we are looking for partners. As I mentioned, we have finalized the development and the production facility, everything is prepared. Now we are looking also for sales partners, because especially in the international content, local partners are always best to enter a market, because they know the language, they have the experience, they have the context to the different people. So therefore, we are looking for partnerships in different countries, and the idea is to provide them a possibility to expand their existing portfolio. For example, people have already one wind turbine, or they are already in the photovoltaic segment, or they are working with storage devices. Maybe they are interested in adding a product like a small wind turbine to their assortment. And they should have experience with the installation of wind turbines. We, of course, will support them. We will train them, give them technical advice and technical support. As I mentioned, also in the solar and storage sector, this is the companies we are looking for in the next steps. So that is a little bit an overview of the journey we have made here, also together here with the people from the Focus Center, where we are now, and now is the next challenge. It will be the market entry. So thank you very much for your attendance and for listening. If you have questions, you're welcome. Thanks.
You, Otto. So we have one question from Ignacio. Just go ahead, Ignacio, unmute yourself.
Hello, morning. Thank you, Otto, for your good presentation. It has been very interesting, your details about the design. But I have a question about the specific cost of this wind turbine. What is the target for the specific cost, the cost per kilowatt of this new wind turbine? Sorry, can you hear me?
Sorry. Okay. On one hand, you can calculate the return on investment on the product. On the other hand, you can also calculate it. What does me a kilowatt cost? This is depending on the different locations. You know, if you have a low wind area, you maybe create only 4,000 kilowatt hours per year. If you're on the coastal side or on a very good situation, you can create up to 10,000 kilowatt hours. So if you want to have a profitability analysis, you have to know the environment you are working in. In principle, I have to say, photovoltaic is, as of today, unbeatable in terms of cost of energy production. It's a matter of fact, we cannot ignore it. But a lot of people who have their photovoltaic installed as of today, and now we are in September, October, they feel very quickly that the energy production via photovoltaic is going down. And then we come with the strength of the small wind turbines. Because this gap in autumn and winter, we can close with our wind turbines and say, now we can support you in securing the energy availability also in this period. So in the end, it will be the optimized structure will be always a hybrid system, having photovoltaic, having small wind turbine, having a storage behind, and then balancing the differences in day and night and summer and winter. That would be the optimal structure.
Okay, thank you.
I hope I could answer you a little bit the question you were asking for.
Yeah, okay, thank you, Otto.
Sorry?
It looks you answered. Okay. Yeah. If he's not complaining, I guess it's okay.
Okay.
Other questions from the audience? Otherwise, which countries are you targeting?
We are starting here at the moment here in Northern Europe, but then we want to expand to South Europe. We had recently got a request for Australia. It depends really on what kind of customer is contacting us or wants to make a partnership with us. It depends a little bit on the countryside and the requirements of the countryside. So for example, in Denmark, we are at the moment preparing the certification, which is necessary in order to enter the market. Other countries is less complicated, like Netherlands, which is easier to go in these countries. Or we have to, like say, the US market. It's interesting because they have very good environment at the moment for starting in the US, but technical requirements has to be adapted. So that will be a second step or a third step. We start in Northern Europe, and then it depends on the partner who is coming to us and based on the discussion that we are following.
And then we have a question from Robert. What is the cost of the system?
That depends on where the customer is living and what kind of market price is possible. At the moment, I have to say we have some projects running in Germany, but in the end, it has to be country by country. It will be evaluated because you know we have done a two-step distribution, a business to business concept, and we have to come from the market and we have to come from the cost price, and then in between, two partners have to be happy with that. So this is really depending by country.